We are from ROS Academy faculty team, and today we'll learn course Olympiad class, subject Physics, chapter Physical Quantities and Measurement. For obtaining similar video explainers, please connect ROS Academy at 8910-890-311, repeating the number again, 8910-890-311, or another number 8910-600-503, repeating the number again, 8910-600-503. All right, let's dive right into this. Welcome everyone to this foundational explainer on physical quantities and measurement. I am absolutely thrilled to guide you through this today. We're going to break down some of the most fundamental concepts in physics, literally the rules that allow us to describe the physical world around us in a precise, scientific, and most importantly, understandable way. So grab your notes, get comfortable, and let's start building this crucial knowledge. Here's a quick look at our roadmap for today. 1. Why measure? 2. Volume. 3. Area. 4. Density and speed. And 5. Connections. First up, Section 1. Why measure? The backbone of science. Moving right along to Section 2. Volume, solids, and liquids. So, what is volume exactly? Simply put, volume is the amount of three-dimensional space that an object occupies. Picture this. Imagine filling a cardboard box completely to the brim with water. That total amount of water, that's the box's volume. Or think about blowing up a balloon. All that empty space inside the balloon is its volume. Every single solid object, every liquid, and yep, even gases, occupy volume. In physics, the standard SI unit we use to measure this 3D space is the cubic meter. Now for smaller, everyday things, you'll probably use cubic centimeters or milliliters. And fun fact, 1 milliliter is exactly equal to 1 cubic centimeter. Now measuring a solid, regular box with a ruler is pretty straightforward. But what about liquids? Liquids don't have a fixed shape at all, do they? They just take the shape of whatever container you pour them into. So you can't exactly hold a ruler up to a puddle. Instead, we have to use specially designed graduated containers, like a measuring cylinder, which have these precise volume markings etched right onto the side. But here's a really important trick. Water actually forms a slight curve at the surface, which is called a meniscus. It curves downward into this concave shape. So to get a truly accurate measurement, you absolutely must bring your eye level straight down to the bottom of that curved surface. Okay, take a look at this visual cheat sheet for regular solids. These are the 4 core formulas you'll absolutely need to have memorized for your Olympiad exams. First, for a cube, all sides are equal, so the volume is just the side cubed. Simple enough. For a cuboid, which is basically a standard box, it's length times breadth times height. Then we have a perfectly round sphere, where the volume is 4/3 pi r cubed. And finally, the cylinder, which is pi r squared h. Take a mental snapshot of this right now. Whenever you run into a volume problem, your very first step is to figure out which of these 4 shapes you're dealing with.
All right, Section 3, Area, Measuring 2D Surfaces.
Now, it is absolutely vital that we don't confuse area with volume. Volume deals with 3 dimensions, length, breadth, and height, or depth. Area, on the other hand, strictly measures the flat surface enclosed by a 2-dimensional figure. It only cares about length and breadth. There is 0 height and 0 depth involved. Because it's only looking at 2 dimensions, the SI unit for area is the square meter, not cubic. We all know the formula for a rectangle's area is just length times breadth. But what if you need to find the area of something completely irregular, like a leaf? You can't just plug that into a standard formula. Well, this is where scientists use a brilliant little trick called the graph paper method. You place the irregular shape on graph paper and carefully trace its outline. Then you simply count all the completely enclosed squares inside that outline. Let's call that number A. Next, you count up all the squares that are more than half enclosed, and we'll call that B. You completely ignore any square that is less than half enclosed. Finally, you just add A and B together and multiply that sum by the area of a single square. It's an incredibly clever and reliable way to estimate the area of basically any flat irregular object.
Let's move to Section 4, Density and Speed, Compound Measurements.
Taking a look at compound measurements, density is fascinating because it connects mass and volume together into a single concept. It's essentially the mass per unit volume, calculated as d equals m over v. It's the exact property that dictates whether an object will float or sink. Meanwhile, speed connects distance, which is, at its core, just a length measurement, with time. That one is calculated as s equals d over t. Notice the pattern here? Both of these compound concepts are really just ratios of 2 other fundamental quantities.
Okay, listen up, because before we move on, I want to give you a massive advantage for your exams. I'm going to highlight the two most common pitfalls students make when calculating these quantities. First up, using the diameter instead of the radius. Guys, if a problem gives you a cylinder with a diameter of 14 centimeters, you must have it to find the radius, so 7 centimeters, before plugging it into your formula. Forgetting to do this is incredibly common. Second pitfall, mixing your units. If your mass is in grams, your volume has to be in cubic centimeters so your density correctly calculates as grams per cubic centimeter. Never ever mix SI units with CGS units in the exact same calculation. You've got to keep it consistent.
And finally, Section 5, connecting concepts, tying it all together. You know, physics isn't just a random list of disconnected formulas that you have to blindly memorize. It's actually a beautifully logical system. Right at the center of it all is measurement. From there, we branch out to 3D space with volume and 2D surfaces with area. Then, we take those spatial measurements and combine them with other physical realities, like mass to get density, or distance and time to get speed. Every single concept builds directly upon the other, creating this perfectly structured way for us to describe the material world around us. So the next time you look around, think about how these measurements are actively being used out there in the real world. Architects are calculating area and volume every single day to design safe, well-ventilated buildings. Doctors precisely measure the density of fluids and the exact volume of life-saving medications to treat their patients. These aren't just textbook formulas. They are the foundational building blocks of our modern world. This was an initiative from Roy's Academy faculty team, and today we've learned on course Olympiad Class 7, Subject Physics, Chapter Physical Quantities and Measurement. For obtaining similar video explainers, please connect Roy's Academy at 8910-890-311. Repeating the number again, 8910-890-311. Or another number, 8910-600-503. Repeating the number again, 8910-600-503.